Welcome everybody to this weekly or bi-weekly call, CSIG, which happens US Eastern 10:30, typically on Wednesdays this year. In the past, it used to be on Thursdays. Now, the theme of the course typically around AI and machine learning. And today we're delighted to have Alejandro Saucedo from the Institute for Ethical AI and ML. Over to you, Alejandro.
Awesome. Yeah, thank you very much, and thank you everybody for putting some time on your day to dive together into the state of production machine learning in 2020. Just to cover a little bit about myself. So, as Sam mentioned, I am the chief scientist at the Institute for Ethical AI and Machine Learning. I'm the engineering director for machine learning at Selden here in London. My background is primarily as a practitioner, so I've been involved in large-scale machine learning projects across various sectors, and this is kind of like an insight on trends that we're going to be seeing for this coming year. A bit more about both the Institute and Selden, so my current roles. Selden is an open source machine learning orchestration organization with a open source framework that allows you to deploy your machine learning models in Kubernetes clusters and be able to scale to thousands. And the Institute is a research center based in London that focuses on highly technical research around different areas like explainability, privacy preserving machine learning, and adversarial robustness between others. The Institute is part of the LFAI, which is a sub-organization of the Linux Foundation, which is primarily focused on both projects that target AI and machine learning, but also try to provide best practices around this space. And this is a very interesting initiative that I recommend people to check out in LFAI. I think Foundation. Yeah, if you check it out. So now let's actually dive into why we're covering this topic and the motivations behind it. So data science projects, they work relatively well when they're small. We have a process that has been widely accepted to follow best practices when approaching a machine learning or data science project. We get some data, we define some features, select a model, define some scoring metrics, and then rinse and repeat until we're happy with the metrics. And then once we're happy, we persist that model, code, and then make it available for consumption of unseen data so that it can predict whether it is for use cases in automation or insights. However, as our data science requirements grow, we face new issues, and this is something that larger organizations and even growing startups are starting to face once their data science teams go beyond maybe 5, 10, 15 individuals. And this includes increasing complexities in flow of data. So perhaps your cron tab that you were using to run multiple jobs across the day is no longer scaling, and you may have multiple different flow of data and jobs that have much more complexity in how you can manage it. Each data scientist has their own set of tools. Some love TensorFlow, some love R, Spark, and some love all of them. And each of those tools is relevant for different use case. And serving models, it becomes increasingly harder. More governance challenges, compliance, as well as just the challenge of orchestration at scale. And when stuff goes wrong, it's hard to trace back. Was it something that needs to be fixed in data engineering, data science, software engineering? It's hard to understand when there's so many moving pieces. So something that we can agree in this premise is that as your technical function grows, so should your infrastructure. And this middle layer is what we're going to be referring to as the components that help us go into that production machine learning piece. And it's a challenging problem. This perspective in itself, it involves expertise from different areas, data science, DevOps, and software engineering, coming into what we often refer to as machine learning engineering. So the infrastructure underlying core components behind it. And in itself, the good thing is that there is a really good initiative within the Linux Foundation that we've contributed, a lot, which is the landscape, which outlines a lot of the projects that are available for this. And we're not going to be able to cover all of these different subsets and pieces, but we're going to be diving into 3 trends that are going to be quite big within the context of 2020. The principles today that we're going to be covering include orchestration, explainability, and reproducibility. And just to emphasize, there are many, many more. We're going to touch upon some of those, but more importantly, I want to give you the sort of like pointers for you to be able to check out, get more information, and then be able to even contribute back. So let's start with model orchestration. This is training and serving at scale. How do you then take not one model, 10 models, but maybe 20, 100 models, and how do you manage that perspective? And this is a hard problem, right? Because this is computational resource allocation that is already challenging when it comes to the distributed systems world, but now you're adding the challenge of machine learning components that may have very specialized hardware on top. Services with different computational requirements, with often complex computational graphs, components that are reusable and have its own version, and some of them may be even stateful. And we need to be able to allocate the specialized hardware for each of those. It is a really hard problem, even taking out the challenge of machine learning. Adding on top of that technical challenge, you have the perspective of your machine learning engineering points that we already discussed in the previous slide, and then you have industry domain expertise and policy expertise that would be relevant in a highly regulated sector, on a critical environment, on a highly available environment. How do you make sure you're able to identify the best practices, and then even go perhaps one step further and understand the industry standards for compliance within that area, and making sure that the people within the team have the right touch points throughout the life cycle of the project itself. So orchestration is not just a technical complexity when it comes to managing multiple models that are continuously performing real-time inference to gather to provide insights on already very domain-specific complex areas, but you also have the human risk around it, right? The impact that it can have on people. So with that comes the ability to be able to take very complex concepts in the machine learning space and abstracting them into IT and operational components, and how you can actually make sure that you would have a simple way of monitoring a broad number of resources without having to go into specific complexities for each of them, right? You don't want to have one metric for one for the other, but you also don't want to have small or a very short amount of coverage in the ways that you're monitoring your stack. And what that looks like in practice, this comes widely on the concept of standardization of metrics, right? When it comes to models, you are able to gather metrics similar to what you would have with microservices: number of requests, CPU usage, memory usage, but also you can get other things that are specialized for machine learning, things like accuracy, precision, and recall, things like concept drift that you can monitor, outliers that may come in and out, and perhaps even the cybersecurity aspects of the components themselves that may not be your usual microservice metrics, but perhaps should not be things that you're thinking on every single time that you're deploying a new model. So in that specific case is the standardization of metrics, standardization of errors, and the way that you can diagnose your models. This is perhaps from a microservice perspective, is the inputs and outputs that go into your models, but from a machine learning perspective, perhaps a way to evaluate those, a way to be able to assess errors that perhaps are not just exceptions in your code. It could be errors that would happen on a more sort of probabilistic way, as opposed to just the usual software determinism that you just get an error and you know what's happening. So it's perhaps something that is more specialized to machine learning. And not only you have the complexity of multiple models, but also the complex computational graphs that you have to create, perhaps having different components like outliers, feature transformers, multiple models within a routing set of rules. And that's one of the sort of complexities that does come into something that you want to realize. And in here, I mean, because we only have half an hour, we're not going to be able to actually dive into the examples. But the benefit of all of the tools that I'm going to give you and all of the resources that I'm making available in the presentation and in the Git repo, where you can find the presentation, which is on the top right. These examples, you can walk through them on your very own time. The example that we're going to be covering for the orchestration part uses Seldon Core, the orchestration framework in Kubernetes. And the basic example shows you how to take a scikit-learn model and then containerize it so that we can deploy it into a Kubernetes cluster and we can consume request responses from it. And what this provides you is an idea of how you can get and see metrics from that, et cetera, et cetera. And you can actually like check it out, click it, and try it yourself. You know, this is basically the example. You're going to be first deploying a simple classifier. So I definitely recommend it. You know, it's a very easy way of actually reaching it. I think I've lost where we are for the presentation. Or maybe I just actually clicked on it. Oh, my bad. Yeah, I actually didn't go on a new tab. But yeah, so the basic example, it just shows you how to deploy a single model, but then also shows you how to then redeploy that and be able to manage it. We also have a more complex example that shows you how to introduce a CI/CD sort of walkthrough on being able to do this programmatically without having like the actual developers going step by step, creating the container, pushing the container, running the commands to push it to the cluster. Because in reality, when you're doing this in an enterprise perspective and a more production-ready perspective, you're going to expect most of this thing to actually happen through programmatic automations, right? And that's why this actually shows you how to leverage a specific, you know, GitHub repository, and changes that actually are pushed result in deployment in the cluster, right? So from this orchestration perspective is the ability to be able to simplify and standardize the process that allows you to not only manage the models that have been deployed, but also go into the processes and best practices to make sure everything is in place, audited, and fully traced for models that actually make it their way into production. And then again, more advanced example, you can try it on your own time. And again, it's open source. It's possible to contribute back if there's something that you'd rather try out instead. Other libraries to watch in this space, if you go into the landscape or into the list that we're going to cover, there's going to be maybe 10, 15 plus other libraries that you can try. So please, feel free to try them all. In this case, I want to point people to several others that I've used and we've used that we also recommend. The first one is KF Serving. So it's also a model orchestration framework for Kubernetes. The difference is that it uses Knative underneath, which means that not only you can leverage the benefits of Kubernetes to scale up a model to be able to receive more requests, but also it can scale down to 0 and have the benefits of a serverless framework. So you can actually avoid utilizing resources when something is not being used. So KF Serving also has a lot of components, and we are as Seldon core contributors of this library within the Kubeflow project. Deep Detect is another one which is a little bit different. It's not Kubernetes specific, but it actually provides a unified API that then connects into other libraries behind. Now, for explainability, this is the second thing that we're going to dive today. So this is basically like tackling the black box model situations. And this is basically asking the question of not only providing ways of opening up the algorithms themselves, but actually going beyond the algorithms. I have a talk that we gave at the PyCon in London, which you can check out if you have time, where we actually dive into 45 minutes of explainability. Each of these topics we can spend an entire hour on. But the main premise of that is that you need to go beyond the tech, and it's also about the touch points, about the processes, and the proposal that we have is an extension to that initial data science process that we showed at the beginning, and extending it to add the steps of data analysis, model evaluation, and production monitoring, right? So in data assessment is assessing class imbalances, protected features, correlations. On model evaluation is assessing things like feature importance, what makes the model predict what it predicted. And then production monitoring is then, once it goes live, the life cycle of the model only begins, what can you make sure you track to make sure you are actually understanding the potential risks and getting insights that perhaps are domain specific, right? And again, we have an example here where you're going to be able to deploy, in this case, a loan classifier, whether somebody should get their loan approved or rejected, and then a subsequent explainer that you'll be able to interact so that it would reverse engineer the model by asking it or sending requests using in this case, anchor explanations from one of our open source libraries with Seldon called Alibi. And this again is open source and is available for you guys to try it out. And the example, you can reach it at bit.ly/Seldon explainer. It's very interesting because it introduces the concept of a infrastructure pattern that abstracts a very complex data science concept of explainers, and it provides it as an infrastructure component that, as an operations manager, for example, there needs not to be in-depth understanding of the concept of the machine learning explanation algorithms, but just the fact that it's an explainer that is part of that sort of graph, right? So from an architectural perspective, it simplifies and abstracts a lot of the complexity into things that can be just, I guess, not drag and dropped, but used in discussions when talking about productization of productionization of machine learning. Other open source libraries to watch, ELI5, so explain like I'm 5, it's called. They're one of the very famous tools that definitely has been widely used in the space. SHAP, is one that I think when explainability algorithms are used, that's definitely one that comes up. XAI is one that we've launched, and then I think Jim, that is on the call. I guess of course you have the IBM Explainability 360. That is also one of the more popular ones, which is also worth checking out. And then reproducibility, model and data versioning. So this is the question of, okay, well, we've chatted about deploying models, we've chatted about analyzing models, but now let's chat about the models themselves and the graphs themselves. And this is the concept of how can you make sure that if you run something tomorrow, you have the same results than today. That proposal of how we've actually broken it down into the conceptual perspective is actually breaking down the concept of a model into 3 constituent parts. Data that comes in and out, the code or configuration consists of this sort of like model. And if you're able to get all of those points at a specific time, you can then rerun it later and you're going to get the same results, as long as the code, the configuration, the data in, and the data out is there. And the challenge is that going one level higher, not only you may have a need to have reproducible components, but you may have also computational graphs that you may want to also be able to store to say, hey, look, this is what my model looks like of today with this component, and you want to store what it's all around every single part, abstracting the entire pipeline. And that's why the complexity of machine learning in production is harder than just microservices. It's a different paradigm. And the hands-on example that we use for this specific use case is using this framework called Kubeflow, for which we're also core contributors for. It's a framework that is cloud native, runs in Kubernetes for reusable machine learning pipelines. And the example that we use, it basically allows you to build a NLP pipeline that actually does hateful speech classification using a Reddit data set. And you basically are able to train 4 components: preprocess, text cleaner, tokenizer, logistic regression model, so that you're able to get a specific input and then predict whether it's hate speech or not. From that perspective, I recommend trying it out, primarily as it provides an introduction of how that works, and you actually go into the step of deploying it, which is very useful. Another libraries to watch in this space: reproducibility, data version control, the more popular components in this space. What this allows you to do is, in a similar way, you add your data, commit code input, etc., and then add repository and then push to a specific location so that you have an idea of what are all the changes that have come through. Another library is MLflow. This is Databricks' library, which allows you to track also all of the metrics as you train your model, and then be able to save the specific model that you train and the accuracy or specific metric that you were using. So here you can see that. And the last one is Pachyderm. So Pachyderm is a, as they call it, like full compliance machine learning pipeline, which allows you to train models and save everything at every single component from that perspective. So these are some of the libraries in the reproducibility area. And one thing to emphasize, is today we covered 3 pieces of this sort of ecosystem, but there are a large number of different components, and there are some. There is a list that we recommend you to check out, which is again on the Ethical ML, called Awesome Production Machine Learning. And in here you can actually see a list of a lot of the libraries for each of the areas that you can dive in. One of the ones that we added recently was feature engineering automation. Feature stores, actually. We added feature stores. And I saw Susan is asking for questions. I'm just gonna give some time for people to think of questions to ask. You can also ask them in the chat. Before jumping into questions, I also want to provide another resource that we also maintain, and we're looking for people to contribute, which is not, in this case, on open source tools, but it's on artificial intelligence guidelines. So I guess this is on the slightly more boring part of the machine learning side, but this is a list of, instead of just open source libraries, this is, I guess, open and available frameworks and guidelines, principles, processes and checklists, interactive and practical tools, online courses, and even regulation and policy, which is, still equally important and, continuously maintained. So for both of those resources, definitely would be very keen for people to jump in, check it out, and contribute. And conscious that we have still 4 minutes, I could still continue covering this, but I want to give some time for questions. So yeah, I'll pause there for a few seconds to see if anyone wants to jump in with questions.
Questions, anybody? Can we add PMML, PFA, Onyx to industry standards list from Svetlana?
PMML. So actually, PMML is, we have a section on model serialization formats, which, if you have other model serialization formats, I would love to add it. So PFA, yeah, we have PFA there.
And Onyx is there.
Onyx is there, yeah. And actually, Onyx recently joined the Linux, the LFAI, Linux AI Foundation, which is, amazing news from that perspective. This list actually went into what is now the landscape, and the landscape has some more sort of like focused set of a nicer sort of like overview. And this one is also open source. You can actually contribute to the YAML. You just need to provide an image. But if you find one that is not available there, just let me know and we'll definitely add it. But yeah, so we continuously push new things that we find here into the Linux Foundation landscape. But yeah, like Svetlana's suggestion, if you find a library later on, feel free to add it. Also, if you want, again, keep updated from news about this related stuff, we have a newsletter as well. So yeah, feel free to join that. The last newsletter covered, Google Research 2019, Facebook Open Source Year in Review, etc., etc. But yeah, we have a lot of work streams with the Institute, and enough open source projects. If anyone is feeling like submitting some PRs or adding issues, would definitely be keen.
That's great. Thank you so much, Alejandro. Looks like there are no questions. Oh, I'm getting an echo. I wonder if somebody unmuted themselves. I don't think so. Okay, well, thank you so much. And I'll leave the chat open for a bit longer in case anybody has something. And Alejandro, if there's anything you'd like this community to help with, like with the guidelines or whatever, any opportunities, do also let us know. Because a lot of the people here are very enthusiastic and they're thanking you for the nice presentation as well. So please do thank Alejandro in the chat if you enjoyed the talk.
Yeah, thank you everybody for joining. Yeah.
Yep.
Yeah, I see a lot of things on the comments, so I appreciate that. Yeah, if you're in any of the upcoming conferences that I mentioned previously, so FOSDEM, KubeCon, the London Strata, I'll be giving a talk specifically on MLOps. So yeah, that'll be do drop by, say hello.
Great. Thank you again, Alejandro, and looking forward to hearing more from you later in the year. And good luck with all your exciting activities.
Thank you. All right. Well, thank you very much, everybody.